Fossils of dinosaurs have survived for millions of years because of a process called fossilization, which preserves their remains under specific conditions. This process doesn't happen to every dead organism, but when it does, it can protect bones, teeth, and even impressions for an incredibly long time. The key reason these fossils didn't melt or disappear lies in the unique way nature can preserve hard materials under the Earth's surface. When a dinosaur died, its body had to be buried quickly by sediment like mud, sand, or volcanic ash. This fast burial was essential because it protected the remains from weather, scavengers, and bacteria that would normally break down organic matter. Without this kind of burial, the remains would have completely decayed over time. But under sediment, the body was shielded and remained mostly undisturbed. Over time, the soft tissues of the dinosaur would decay, but the harder parts, like bones and teeth, remained. As more layers of sediment built up above the buried body, pressure increased and mineral-rich water flowed through the remains. This water carried minerals that began to slowly replace the original organic materials in the bones, turning them into rock. This replacement process is called permineralization. Permineralization is the reason why fossils are not made of the original bone but of stone. The minerals filled in the empty spaces within the bone and hardened, creating a rock replica of the original structure. Because of this, fossils can last for millions of years without melting, rotting, or disintegrating. Fossils are usually found in sedimentary rock. These types of rocks form in layers and are much gentler than igneous or metamorphic rocks, which form under extreme heat and pressure. Sedimentary rocks provide the right conditions for preserving fossils over long periods. That's why fossils are often discovered in these kinds of environments. Another reason dinosaur fossils remain intact is because they were buried in areas that did not experience extreme changes in temperature or moisture. Stable environments slow down chemical reactions and reduce erosion, making it easier for fossils to survive. If the bones had been exposed to high heat or strong acids, they would have broken down much faster. Erosion plays a role in eventually revealing fossils, but it can also destroy them. Luckily, many fossils remained hidden beneath the earth for millions of years, protected by rock layers above them. Only recently, due to natural erosion and human digging, have these fossils come back to the surface, still largely intact. Fossils do not melt because they are no longer organic. Once bones become fossilized, they are essentially turned into rock. Rocks do not melt under normal surface conditions. Melting would only occur if the fossil were exposed to extreme temperatures found deep inside the earth or during volcanic activity, which rarely happens to fossils that are preserved well. In many cases, fossils are not completely whole, but paleontologists can find enough pieces to reconstruct the shape and size of the dinosaur. Sometimes, the bones are slightly crushed or cracked, but they are still preserved well enough to be studied and displayed in museums. This partial preservation is still incredibly valuable to science. The age of a fossil is not determined by how fresh it looks, but by the layers of rock around it. Radiometric dating and the study of sediment layers help scientists determine the fossil's age. Even if the fossil looks hard and solid, it has often been through millions of years of chemical and geological change. The preservation of dinosaur fossils also depends on the absence of oxygen. When buried in an oxygen-poor environment, decomposition slows down dramatically. Without oxygen, the bacteria that usually break down bodies can't function well, which gives more time for fossilization to occur. In some rare cases, parts of the fossil might even retain impressions of skin, feathers, or other surface details. These are not made of the original skin or feathers, but of the impressions left behind in the surrounding rock, which hardened over time. These features are preserved through a process similar to casting, where the shape is recorded in the sediment. Some fossils are even found in mineral-rich areas where special preservation happens, such as petrification. This results in fossils that are remarkably detailed and durable, further preventing them from breaking down or melting over time. The chemical environment of the soil or sediment plays a major role in how well a fossil is preserved. Human efforts also contribute to the preservation of dinosaur fossils. Once discovered, fossils are carefully excavated, stabilized, and stored in controlled environments to prevent them from weathering or degrading. Museums use temperature and humidity controls to make sure these ancient remains are kept safe for future generations. In conclusion, dinosaur fossils didn't melt because they underwent a natural transformation that turned them into rock. This transformation preserved their structure and protected them from the forces of decay and destruction. Nature, time, and the right environmental conditions worked together to make sure these remnants of the past could still be discovered and studied today.